Welcome to Legend Lines, and today we're going to have a look at powers of a polar complex number, powers of a complex number. So now we have this complex numbers, z1 being equal to that, z2 being that, and then z3 being this. Now if you are to multiply z1 by z2 and z3, then our result is going to turn out to be R1, R2, R3, multiplying the cos of theta 1 plus theta 2 plus theta 3, then plus I, the sine of theta 1 plus theta 2 plus theta 3. This is because in multiplication we multiply the moduli and add the arguments, as we've already seen in the previous videos. Alright, so now suppose that z1, z2 and z3 are all the same, or are all equal, such that z1 is equal to z2 is equal to z3, and then they are all equal to r, the cos of theta, plus I, the sine of theta. And the result above becomes z1, z2, z3 being equal to z cubed becomes r by r, multiplying the cos of theta plus theta, then plus I, the sine of theta plus theta. And this turns out to become r cubed cos 3 theta plus I, the sine of 3 theta. So now the result here shows that if we wish to cube a complex number in the polar form, we just cube the modulus, which is the r, and multiply the arguments by 3. Similarly, if you want to square a complex number in the polar form, we square the modulus and multiply the arguments by 2. Alright, so now let's generalize it and say you have a complex number z, and you have to raise it to a certain power, that is n. Then we should get r n, because we have to raise the r also to the n, then multiply the argument by n, so you get I sine of theta. Now this general result is very important, and it is what we call the DEMOIVRE'S theorem. DEMOIVRE'S theorem, which actually helps us to find the powers and then the roots of complex numbers. So when I had to find the square root, it actually raising this complex number to the power half. Similarly, the cube root, then to 1/3 of that. As simple as that. It's very important. And so it states that to raise a complex number in polar form to any power n, we raise r to the power n and multiply the angle by n. That is the DEMOIVRE'S theorem. Very simple. So let's take an example and see what happens. Alright, so guys, as we've already established, that if you are to raise a complex number to a certain power, you just raise the radius to that power and multiply the angle by that power. And so with this, we square the 4 and multiply the angle by 2. So we get I, the sine of 2 by 50. And our answer becomes 16 cos of 100 plus I, the sine of 100. As simple as that. With the example 2, we are to find the square root of this particular complex number. And so square root of z actually becomes z to the power half. So simply we raise the 4 to the power half and multiply the angle by half. So the square root of z becomes 4 power half, then cos half multiplying 70 plus I, the sine of half, multiplying 70. And our answer turns out to be 2 cos of 35 degrees plus I sine 35. So that's all about the DEMOIVRE'S theorem. Thank you very much, guys. Please subscribe to stay connected. Thank you.